Hey everybody. This video is coming to you from Canada. Yes, the nice snowy winter wonderland up north. And today we're going to be looking at solving simple equations. Variables are going to be on one side and another side. We're going to review some of the basic algebra rules, and we're going to talk about the golden rule of algebra. What might that be? What you do to one side, you do to the other. Okay, let's get to the example, shall we?
Okay, so we're going to be looking at solving simple equations. Now, the very first thing that we need to talk about is going to be the golden rule. So, the golden rule in life, of course, is treat others how you would want to be treated. Maybe that's the most important rule of them all. But when we're talking about math, I want you guys to be thinking about a seesaw or a teeter-totter. And these are always fun when you're a kid. You kind of sit on them. And depending on you and your friend, if one was bigger, it would go up or down. Or if you're exactly the same size, you would be completely parallel and even to the ground. And what would happen is, if we could add a brick to one, the teeter-totter would then push this person up. So that's the idea we're going to use for math, because the golden rule for math, the golden rule, perhaps the most important thing you're going to hear, is what you do to one side, comma, you do to the other. That's it. If you follow this rule, you will be successful in math. So what does this rule look like for the teeter-totter? What should have happened? If I added that red brick to that side, that just means I need to add the red brick to this side. Now we're going to be talking about math. This part here, which, fun fact, is called a fulcrum. This is like the equal sign. It's right in the middle. So let's take a look at what this is going to look like for math. Well, for math, we're going to be talking about equations. So here, let's just grab a nice, easy equation. X plus 2 is 10. So x plus 2 is 10. And our goal is to basically say, I want to get x all by itself. All by itself. And this equal sign is like the fulcrum. So there's the left side of the equation and the right side of the equation. Sometimes kids think that the middle of the equation has to be exactly like literally in the middle. So like down here kind of thing, right? But no, wherever the equal sign is, that separates the left side and the right side. So ask yourself, how can I get x by itself? How do I get rid of the positive 2? Well, I would just go and subtract 2. Following the golden rule, I would do it to this side as well. And what do I end up getting? Well, 2 minus 2 is 0, so it just leaves me just with x. And 10 minus 2 is just going to be 8. You would probably rewrite this a little bit neater, so x equals 8. So that's the golden rule. Not too bad. Let's take a look at what it looks like, though, in other situations. So in other situations, let's take a look at a multiplying one. Let's say you had 2x. We'll just say 2x is equal to 12. I always like to think of opposites. So what is happening? What is happening right between the 2 and the x? What's happening there? Well, there's multiplying. So think of what's the opposite of multiplying by 2? Dividing by 2. They kind of go hand in hand. So I'm going to go and divide by 2. If I do it to one side, I must do it to the other side. And what happens here is when 2 is divided by 2, becomes 1. So it basically eliminates this, leaving you just with x. And 12 divided by 2, let's do that, is a 6. So there's an example where that kind of happens. Let's kick it up another notch. So let's go and see kind of what would happen. Let's bring that back, and maybe I need to go and just erase all this. Can I erase all this? 1 second. Let's see. Well, there's my teeter-totter. There's my other equation. Interesting. Maybe I can just do this. Sorry, it's my very first video, really, trying to get used to all this kind of stuff. So let's see. Let's kick it up a notch. Let's go 4/5 x is equal to 6. Now, some people rewrite this as 4x over 5 is equal to 6. Same thing. Exact same thing. There's 2 ways to solve this one. So there are 2 ways that you might want to go about solving this one. And I'll show you both. One way is to say, again, 4/5 is multiplying by x to get to 6. What's the opposite of multiplying by 4/5? A lot of kids will say dividing by 4/5. So I could go and divide both sides by 4/5. Now, going back in some of your math experience, you know that if you divide something by a fraction, you are really multiplying by its reciprocal. So what some kids like to do and think of, and I am one of those, is I like to say, instead of dividing by 4/5, you're multiplying by the reciprocal. So I'm going to multiply this by the reciprocal, like that. Notice this is the exact same thing as that. So I'm kind of saving some time. And I like saving time. So 6 times 5/4. Well, I like to always kind of put this over 1 just because then it kind of looks easy. Remember when you're multiplying, you're going across the top and you're going across the bottom. So that is going to leave you with 6 times 5, 30 over 4. And you're going to go and simplify that to 15 over 2. So, final answer, x would equal 15 over 2. Now, over here, what happened here? So why did I do that? Well, these all cancel each other out, leaving you just with x. So it's a great way to do that. Okay. So that's for those ones. I'll show you another one that always is popular. So let's see this one. I'm going to show you guys if you're kind of new to my stuff, I'm going to show you a KKM. This is a common kid mistake. Hopefully you're laughing right now because it's funny. And if you don't get it, you can send me an email and I'll tell you why it's funny. But common kid mistakes. Here's one. And let's say you had 2x over 3 plus 5 is equal to 12. And you're like, I remember what I need to do. I need to multiply by the reciprocal, by 3 over 2. And I'm going to multiply this by 3 over 2. And, you know, it was pretty cool. I know that this all gets eliminated. Boom, like that, leaving you with x. And over here, I think that would give you like 18. So I'd have x plus 5 is 18. I would go and I would subtract both sides by 5. And I would get x equals 13. Yay! And I would be all happy, like, I rock. This is awesome. Well, you would be wrong. Because a couple things is when you multiply this side by 3 over 2, notice I said side, so you would need to multiply this 5 by 3 over 2 as well, which a lot of kids forget. Common kid mistake. So let's just step back in time. Let's go back in time. The magic of technology. And step back to here. Actually, I might even need to do some erasing here. And go let's get rid of this right now. And let's get rid of this. You need to, and I'm going to go and just rewrite this because I want to make sure it's nice. You would have to go and subtract both sides by 5 first before you did the multiplying. Okay? So now you would get 2x over 3 is 7. Whew. Now you would go and multiply both sides by 3 over 2. And you would get x equals 21 over 2. Hopefully your teacher lets you leave your answer in improper form. Okay. So a couple of things. Last one. This one always kind of gets kids for solving some simple equations. Let me get a new layer here. These ones. X over 3 is equal to 4. So x is being divided by 3. What's the opposite of dividing by 3, everybody? It would be multiplying by 3. So I'm going to multiply both sides by 3. And when I do that, I get to go and cross out these 3's. And I'm going to be left with x equals 12. And where was I? That is x equals 12. Let's take a look at a few other kind of examples because we're going to be starting to kind of get into stuff with maybe some symbols. And I also want to talk a little bit about absolute value as a refresher because sometimes we forget about absolute value. So let's just take a look at something that might look weird and kind of scary, but it's not that bad. So we're going to throw this equation at you. Let's say you had d, it's my favorite variable, minus 6 pi is equal to pi. And you're like, what is going on? And I said, you need to go and basically solve for d. Well, okay, we'll just calm down. You say, I need to get d all by itself. So how can I do that? How can I get rid of this negative 6 pi? What's the opposite of negative 6 pi? Well, positive 6 pi. So I'm going to add positive 6 pi to both sides. And what's 1 pi plus 6 more pi's? You might start getting hungry. It's 7 pi. That's your answer. It seems kind of weird leaving it like that, but that's your answer for that. Let's see a couple more examples, then we'll kind of be done. I also want to talk a little bit about absolute value as a reminder. So let's say you had something that has maybe some multiple steps. So let's say we wanted to go and solve this question. So negative 2 is equal to, let's go back to x. And let's add 12 divided by 3. Hopefully you guys remember BEDMAS for order of operations. Your teacher might have said PEMDAS. Same thing. So we need to do some order of operations first. So this 12 divided by 3. So here you get negative 2 is x plus 4. And then you say, okay, how do I get x all by itself? It's on the right-hand side. Don't freak out. It's fine. Leave it on the right-hand side. No worries. I'm just going to subtract 4 from both sides. And negative 2 minus 4 is negative 6. And that's going to be equal to x. And there you go. Just leave it like that. Maybe your teacher wants you to rewrite it as x equals negative 6. That's fine. Kids feel more comfortable on the left-hand side like that as opposed to the right-hand side. Last thing for this little section. You're doing awesome. Hopefully you've laughed at a few of the jokes. KKM is still my favorite. Absolute value. Let's talk about absolute value. So absolute value are those things where you have bars. And remember, absolute value just basically says, what is the distance to 0? How far away is negative 7 from 0? It is 7 spaces. In kids' kind of language, do all the work inside the bars first. And then whatever the number is in there, it has to be positive. So for this one, what's negative 3 plus 7? It's 4. Okay, is 4 positive? Yes, so your answer is just going to be 4. What's the common kid mistake for this one? Can you guess what the common kid mistake is? What's the KKM? Well, the common kid mistake is to go and convert this to 3 instantly. And say 3 plus 7 is 10. What's the absolute value of 10? It's 10. No. Do all the work inside here first, and then do the absolute value, so you get the answer of 4. Let's go and apply this idea now to solving a question, and then we're all done for a little bit. So let's say we had this. Let's say you had 16 is equal to W minus the absolute value of negative 7. Okay. Well, you just learned that you must do the absolute value first. So what's the absolute value of negative 7? 7. Was this minus sign inside there? No. So it just stays there. And the W stays there. And this is what you are left with. 16 equals W minus 7. Let's go and add 7 to both sides. And we now have 23 is equal to W. And there's your answer. Awesome. All right. Hopefully you guys have gotten some stuff on this one. And you've enjoyed it. You can take a look at some challenge stuff in a second. But thanks for paying attention. Great job, everybody.
All right, so that's what we would consider standard level. But what would challenge look like for this? Well, we're going to start exploring complex fractions. Ooh. All right, let's check it out.
Okay, so let's talk about challenge. For challenge, we are going to be looking at complex fractions. So what does complex fractions mean? It sounds scary, but it's really not. I always talk about it as basically being a fraction over a fraction. Let's see what I mean. So here's a friendly little fraction. This is 3/5, and now we're going to put it over another fraction, 7/8. Now, if I asked you, is there another way that we could actually go and rewrite this? Well, we could write it as 3/5. And what does the bar there mean, the fraction bar? It means divide. So I can put down this is actually 3/5 divided by 7/8. And that's not too bad. We know the rule. To put it in kids' terms, you just flip the second one and you multiply. So we end up getting 3/5 times 8/7. And can you do any kind of cross reducing? Nope. So we get 24 over 35. That wasn't too bad now, was it? Not at all. So it's going to be, there's some general rules. So if we want to know like a really kind of cool shortcut, I think this is actually pretty neat. One of the rules is A over B. So this is for any kind of complex fraction, that is a over b over c over d, we can write a rule. We love rules. And some kids like just to take a look at that. It really means a over d times b over c. Okay, so that is the math rule of how complex fractions, I guess, work. There's some things we might want to be looking at in terms of shortcuts when solving these kinds. So let's take a look at what some shortcuts might look like. So let's see, let's grab an orange color. These are kind of cool. So let's say you had something that was a half, and I want to add maybe 3/4, and I'm putting this all over, let's go 5/6. Okay, so 5/6. And now you might want to say, I might want to go and solve this first. There's a really cool trick, is if you look at 2, 4, and 6, so you have 2, you have 4, and you have 6. And you said, what is the LCM? So what's the LCM of those numbers? And you're like, I know what the LCM is. The LCM is going to be 12. Yes, 12. Well, what you could go do is you could go and multiply everything by 12. And that will make things maybe a little bit easier for you and get rid of the denominators. So 12 times a half, what's that going to give you? That's going to give you 6. And what's 12 times 3/4? That is going to give you 9. And what is 12 times 5/6? Good question. That's going to give you 10. So now we have a very simple kind of equation saying, oh, that's just 15 over 10. Now, would you leave your answer like that? Final answer? Of course not. That would make your teacher very sad. You need to go and reduce that, and it reduces to a very happy, after dividing by 5, to a 3/2. Boom, like that. And everybody is happy. So complex fractions, kind of cool.
All right, I hope you guys got a good understanding of how to solve equations. Check out the link that goes to some Khan Academy practice problems. And if you have any questions, put them down below, and I'll try and get back to you. Thanks.